Hi, welcome to ARISTOTHINK. Today I'm going to show you an acceleration problem. We have basically the acceleration of the thrust of a rocket against the acceleration of our own gravity, and I want to know how we can work with. Actually, I'm not very worried about this problem itself, but how we can mix different accelerations on the same object, because when you go horizontal we have to think like this. But I'm taking the rocket as an example. So NASA has these rockets, very powerful rockets, SLS rockets, with 8.8 million pounds of thrust. As you know, this is the strongest rocket we have on our planet. The second strongest one belongs to SpaceX, which is Falcon 9, which has around 5 or 5.5 million pounds of thrust. But I'm taking the biggest guy here, so in our example. And this rocket is going to go up, and I want to know what's going to be the time when this rocket is going to reach the limits of our atmosphere at 10,000 kilometers. This is the rocket engine, and I want to know the time it's going to take. Okay, this is what we're going to do. But usually, how do we solve this problem? Usually, we have the thrust, force of thrust, gravitational force. What we do? Net force, thrust minus force of gravity equals ma. We find A of the rocket, the actual acceleration that this rocket is moving, and then we solve using Kinematics equation and it done. But I'm not going to go solving like this. This is basic, you know this. I want to discuss about acceleration. So let's go. Well, so we have the force of thrust, which is going to be 8.8 times 10 to the 6 pounds Libra force. As you know, if you don't, Libra is the Latin word for pound. So we can't just write pound force. We write LBF, which is Libra force from Latin. Now, the first thing we have to do is we have to change this pound to kilogram. So I know that 1 pound, 1 Libra, is exactly 0.4536 kilograms. Wonderful. Now I cancel Libra with Libra, and now this unit has become kilogram force. As you know, 1 kilogram force is the weight of 1 kilogram. So if I have 1 kilogram here, so this has a force of mg, right? So 1 kilogram force is the same as basically 10 newtons, which is the weight of a mass of 1 kilogram. And that is what we're going to write now. So this is kilogram force. Now I have to change again into newtons. I don't want to work with kilogram force. Kilogram force is not SI units again. So let's go. 1 kilogram force is the same as 9.81 newtons. Why not 1 kilogram force and 9.81 newtons? Because if I do like this, 1 kilogram force divided by 9.81 newtons, well, I want to cancel this kilogram force on top, you see? Now it's cancelled. I'm left with newtons already. If I switch, I'll never be able to cancel numerator and denominator. So this is the same as, if I'm not mistaken, 39.1 times 10 to the 6 newtons, or basically 39 mega newtons if you prefer. Well, so this is the force. Of course, this force is acting on this rocket. It came from the chemical reaction of the fuel and is propelling this rocket. Well, F equals ma. So what's going to be the acceleration that this chemical reaction is giving to the rocket? I don't care about gravity yet. I'm only looking at the thrust, the acceleration that this explosion on the fuel is giving to this rocket. So what's going to be the acceleration? Well, we know that this thrust force is going to give an acceleration for the rocket. I don't care about gravity yet. It doesn't matter. I'm only focusing on this thrust of the engines. So if we go for it, so what is this? 39.1 10 times 26 equals mass of the rocket 2,500 tons. You do the math and you're going to see that this is 2.5 times 10 to the 6 kilograms. We gotta put kilograms, standard units. So times the rocket's acceleration. This cancels out. Okay, and then you're going to realize that our rocket acceleration is 15.6 mass per square seconds. So this acceleration that this rocket is given to this object, to these rockets. But let's just draw to see what's going on. So let's draw in here. Imagine this is our rocket. Now, we have a thrust giving 15.6 meters per second squared. This comes from the engines. But we also have a gravity pulling down. And gravity is 9.81 meters per second. And this is the whole core of my video. I want to discuss this with you today. So we have a body and we have an acceleration on this direction and another one, because there are two forces acting on this object. One force, whenever I have a force, we have MA. So whenever I have a force, there is an acceleration involved. So this force gives this acceleration. Agree? We just did the math. But you also know that we have gravity, another acceleration due to the gravity force. So what's going to be the net acceleration? Well, we just do simple addition, subtraction, whatever you want to say. So the difference is going to be 15.6 minus 9.81. So the net acceleration, it is exactly 5.83 meters per second squared. So basically 6 meters per second squared, it is the acceleration that this rocket is moving throughout the atmosphere. And this is acceleration, we're going to use it. As simple as this. And now you wonder, oh, but no, I cannot just add acceleration and subtract like this. Of course we can. Wouldn't you agree with me that if I have an object and I have a 3 newtons force, and then I have it, let's make different numbers. I have a 5 newton force in here and the 2 newtons force pulling this direction. Isn't it the same of saying that it is 3 newtons into that direction? We just 5 minus 2. You know this about forces, don't you? Now, it is the same about acceleration. Because if you come to look at it, F equals ma, so the difference between force and acceleration is just a constant. And this constant does not even have direction. So if it works for force, it must work for acceleration, because I'm just multiplying by a constant, nothing else. So if I say that acceleration is 15 and you have another one of 9.8, we just do the subtraction and we get the results. So this is basically the exercise. Now let's just apply kinematics and let's solve it. So we have this acceleration. Now I want to know the time. How can I know the time? Well, I'm going to use the basic acceleration. So delta S is going to be V0t plus at squared over 2. Delta S is going to be the atmosphere limits, right? 10,000 kilometers. 10,000 kilometers, again, we have to go to SI units, which is 10 to the 6 meters. So 10 times 10 to the 6th. So this is going to be 10 times 10 to the 6th, because it's 10,000, equals, what is acceleration? 5.83 times square root divided by 2. If you work this out, you're going to get that the time is going to be 1,850 seconds. I'm using only 3 signet figures because it's more than enough. We don't want to go any further than this. And this is the same, about 30.9 minutes. So this is the answer. This is the video, only this. What? I don't know how many minutes, 10 minutes. It's fast. I just wanted to discuss with you this. Why? Why did I want to discuss this massaging with accelerations? Because please take a look at the next video, because the next video is going to deal with the same problem, but it's going to be horizontal. And when it's on horizontal, you might not understand very well. And so if you just think about if you can just understand that you can just add and subtract accelerations, it makes the problem so much easier, so much easier. So if you have an acceleration of 5 and acceleration on this side, this is acceleration, so the net acceleration, it is 3 to these sides. You see, only this. That is why I made the entire video, to show you that we can play with acceleration just like we play with forces. Thank you very much. Please, if you think it was interesting, this video, if you learned something in this style or whatever, please subscribe, give the like. The like is very important so YouTube can distribute, and it shows YouTube that this video is not garbage. It actually serves humanity to do something better. Consider subscribing. I'm always going to send exercises. Of course, they are not going to be as always as easy as this one. They are much more complicated, but sometimes I will stop and give something a little bit more basic to make sure that everybody is on the same pace. And of course, I want to reach as much possible many different types of subscribers and students. Thank you very much. See you next time. Don't forget to watch this other video which deals only about accelerations. See you. Bye bye. Now you just have to find the stop button. Oh, it's here. Bye.